decided that I'm going to do a year of Advent of Code, or month of Advent of Code really, in review, and go over each of the puzzles and kind of rate each of them from 1 to 10, both on difficulty and fun, and go over how I solved each one of them. So I have 54 minutes and 24 puzzles, so I'm going to be able to spend about 2 minutes per puzzle going through what it was about, how I solved it, and what I thought of it. So the first puzzle that we had was day 1, which was called chronocalibration. And the deal with chronocalibration was it's basically the intro to Advent of Code, right? Where you basically have to add up a list of different integers and find out what the sum is, which you could literally do in Google Spreadsheets. And also it asks you to compute the running total and find out whether you reach the same value twice, whether your running total is the same twice. So unfortunately, I wasted a bunch of time here and placed really poorly because I had to do a bunch of effort to create the skeleton because I hadn't created the skeleton yet that year. And as a result, I placed pretty badly. I would say it's kind of a 1 on a difficulty scale and 1 on a fun scale. Not really the most fun of the puzzles, but kind of a good way for people to get started with AOC. So that was the first day. In the second day, we started to get to a place of more interesting stuff, where we need to count strings, right? To count how many strings how many strings contain 2 letters of the same kind versus 3 letters of the same kind. So again, fairly basic string parsing. And then it got somewhere more interesting, which was it got to the point of figuring out, okay, what are the shared characters between the strings, right? Kind of what are the Hamming distances between the strings? And I know people had a bunch of clever techniques, but in my case, I just used a simple map, and I just used Golang's arithmetic using slices of strings in order to check what happens if I omit 1 letter at each location. So that way, it doesn't really matter. You don't have to check, what the difference is between the letters that are omitted. You can just say, okay, these 2 things, were they omitted or not? If they were omitted, then they overlap in all the other characters. Good. Then just increment the number of increment the shared combinations. So that was day 2, which I would consider to kind of be a 2 on difficulty and a 2 on fun. So a little bit more fun, a little bit more challenge, less mechanical, but still not necessarily kind of what I sign up to do Advent of Code every year for. Okay, day number 3. So day number 3 was interesting in that it turns out that I screwed up day number 3. What I did was I originally had a bug in which in this line right here, I was checking X rather than Y against the termination condition. It was infinite looping. So I thought to myself, oh my goodness, I'm never going to be able to solve it just by iterating through. Therefore, I need to do a more complicated algorithm. So I figured, hey, why don't we calculate the corners? Why don't we calculate using rectangular regions? Because clearly it's not performant enough to count pixel by pixel. But unfortunately for me, it's 1,000 inches on every side. It's all integral, so a computer can count to 1,000,000 pretty damn fast. So that was my bad there. So it would have been far faster just to say, look, I'm just going to mark things as conflicted, kind of just one at a time. But, so, if I had done it correctly, this would have been a 30-minute puzzle, but instead it took me an hour and a half, and I'm still a little bit mad about it. So it still was pretty fun, and that it was kind of still not very difficult, maybe a 3 on the difficulty scale. So what I actually wound up doing was I did something super complicated where I was tracking the top, bottom, left, and right edges of the claim, and I was checking I was checking whether any of these squares overlapped. It was hideously complicated. It did get the correct answer, but so it goes. All right, day number 4. So day number 4 was the one with the sleeping guards. In the puzzle of the sleeping guards, what you're supposed to do was you're supposed to figure out how many times a guard winds up being asleep and calculate when are they most often likely to be asleep. And it also had some interestingness with parsing, which was a little bit frustrating. But the interesting thing here was that it was really tricky to read the instructions correctly because of the fact that it was specifying kind of various conditions for tie breaking between the guards that were a little bit tricky to get right. But, you know, perfectly reasonable, perfectly doable. Here, basically, strategy 2, right, like it's changing the condition of what you're looking for as a tiebreaker. So I would say that was kind of difficulty 3 again. The parsing, in my opinion, made it a little bit less fun. All right, puzzle number 5 was kind of reducing uppercase and lowercase, kind of positive and negatives reacting with each other to cause them to disappear. And a lot of people I know here got really, really tripped up by the fact that they weren't slicing the end of the new line off, and they got the wrong number of units remaining. They were literally off by 1. This is a relatively simple variation, which is basically if you take out all units of one kind and then fully react, what happens? So you just need a loop to account for seeing, okay, if I take out all of these things, what is the result, right? What happens if I remove each of these pairs? The other thing that was cool and useful here is you can perform arithmetic in Go on characters in really any language because it's ASCII. So if you add 32, you get you go from from uppercase to lowercase. So I thought this really wasn't that difficult. It was still moderately fun. It just wasn't really difficult. Okay, day number 6. So day number 6 involved, what was that even? Oh, right. Day number 6 involved trying to carve out areas around coordinates to try to figure out which coordinates are closest to one coordinate and which ones are in the border between 2 coordinates and equidistant. And this winds up being a flood fill, which is not horribly, horribly difficult to do. However, if you hadn't seen a breadth first search, this was kind of the first opportunity where you saw it. I happened to find this puzzle was pretty fun. So what I wound up doing was I wound up saying, you know, starting from each coordinate, I'm going to grow in any direction that isn't already occupied by someone else, right? Let's see, part A was, yeah, what's the size of the largest area that's not infinite. And then the other thing that we needed to do was we needed to do a search to find out all the locations that have a distance, sum of distance to all coordinates, not just one coordinate of less than a certain number. So again, you can keep expanding, and avoiding repeating, and then eventually you're kind of tracing the periphery, so it's only about n squared, so it's reasonably fine. So yeah, I found this to, actually I'm going to bump the increment difficulty to 4, because it does involve a search that is a novel and new thing. But I quite like this puzzle. This puzzle was definitely kind of one of my favorites. Okay, day number 7. What happened in day number 7? So in day number 7, this was constructing dependency trees, so trying to figure out, given a list of items and that define kind of what depends on what, how do we actually figure out what order we can do them in, and can we do it in parallel? So this one was hella cool, not because it was especially difficult, but because it was pretty fun. So what I wound up doing was I actually wound up taking each worker and doing a set of operations on the worker, right? So I would, for a given thing that was in progress, tick it if it was already in progress. Otherwise, find something new that was runnable and run it. Hey, Yubi-san. So I thought this was pretty fun. Kind of was about as difficult as the previous one. In fact, I'm going to bump this up to 5. When you have any kind of graph search, I think that it makes it at least halfway difficult. But this one was a lot of fun. And a lot of the fun was basically saying, okay, how are we going to encode the dependencies? And the way that I encoded the dependencies, given that each one was a letter, was I just literally said, look, the dependencies are a map from bytes to lists of bytes. And that way you can figure out, okay, what do I have to finish before I do everything else? So, that was day number 7. That one, again, was one of my faves. Day number 8. So in day number 8, what we had was... We had... Oh god, this one. Okay. This one was a parsing problem where you had to be able to parse just a list of numbers and keep track of what's on your stack, right? Are you currently evaluating the metadata? Are you currently evaluating the children? Like, where are you in the stack of items? People thought that day 7 was going to be super difficult. Oh, I guess if you're not familiar with kind of setting up workers and ticking in parallel, then it can be especially difficult. Fair enough. Okay, so talking about day number 8. I think this one was the first one that really ratcheted up the difficulty, in that it forced you to think about setting your appropriate data structures, including for the first time for a lot of people at least starting to have to think about pointer arithmetic, modifying things in place, and so on and so forth. So I thought that this was pretty challenging. I think that this was actually a little bit more challenging than doing a graph search, because a graph search you can kind of pull out of your college textbooks, but for doing this kind of parsing, if you never had compilers, you'd be really up the creek. But fortunately, I wrote a parser, so this wasn't a big deal. There was just a lot of debugging to kind of get it right. Alright, day number 9. Day number 9 was the marble puzzle, and day number 9 was a case where if you knew about the ring type or circular lists, you had an easy time. If you did not know about those things and were trying to do modular arithmetic, you might really, really struggle. I personally thought it was a 4 in difficulty because I kind of cheated by using the ring class. But I definitely found it to be super fun, right? Like, it's kind of playing a game. So I think that was probably, again, one of my favorite puzzles. So in the puzzle, basically, you had to repeatedly add things to the circle, keep track of people's positions on the circle, and to move forward a certain number of increments each player in the circle. All right, day number 10. So day number 10, I know a lot of people who really struggled or felt day number 10 was unfair or harsh. Personally, I thought it took a step down in difficulty. I think that this one was the first one that didn't really necessarily have an immediately obvious algorithmic solution that you could pull out of a box or a hat. Personally, what I did was I wound up thinking about, okay, how do we define when we're done? And the way that I thought to define when we're done is I went and looked at this right here. When I saw this, I thought to myself, hey, you know what this has a lot of? It has a lot of lines that all have a lot of things in common, like either horizontally or vertically. There's a lot of things on the same line. So the way that I solved it was I did a check and I said, look, if we have 20 stars all in the same vertical or horizontal line, we're probably done. In retrospect, that might not have terminated, and it would have been better to use a bounding box. It would have been better to say, you know what? I'm going to maximize or minimize the total area of a bounding box covering all of the stars. But other than that, it was a pretty straightforward, can you tick a bunch of particles, kind of anyone who did graphics or any kind of computer gaming thing would not have a huge problem with it. But I know a lot of people that were like, crap, I'm going to have to step through this by hand, and I just might blink and miss it. So, unfortunate. Not necessarily super fun. In my case, I didn't find it that difficult. Day number 11. So in day 11, this was the first time that people wanted to potentially use a, whatchamacallit. People might be called upon to use a summed area table. I chose not to use a summed area table. What I did instead was I just memoized, and I said, you know what, I'm going to memorize starting from the upper left. I'm going to just repeatedly carve out the perimeter of a new rectangle, right? So tracing that, and then tracing that, and then tracing that, and so on and so forth. So that's what I did. It was performant enough. It wasn't great, but it was performant enough. So in part A, I just manually did the square evaluate 3 times, and for part B, I ran the memoized computation until I evaluated the whole, I think, 300 by 300 set of coordinates. So that's what I did. I thought it was pretty fun, not necessarily one of my faves, and it definitely, I could see why it might be challenging to someone because it requires you to memorize, but you know, memoizing I kind of tend to do fairly easily on my own, so I don't think it was as difficult as, you know, writing searches or doing other kinds of more complicated stuff like doing complicated parsing and writing a parser specifically. Right, day number 12. So for day number 12, we had recurring pot generation, where we had plants whose state depended upon the status of the 2 pots on either side of them. So it kind of created this situation of where you had this list of patterns that defined, okay, if it matches one of these patterns, cause the plant to become alive, otherwise cause the plant to become dead. And to take the previous input and to use that as the blueprint for the next input. So it required you to be careful about not modifying as you went along, instead of, you know, saying A and B and swapping back and forth between lists A and B. The other interesting thing, though, that it required was, this one was the first one where it said, here's a ridiculous number. Maybe you need to find the repeating pattern. So I know that I struggled a bit with getting the correct answer, but that being said, I did think it was pretty fun. And it was, I'm going to rate it a 5 on difficulty because it had that component of detecting the repeating pattern for the first time. So yeah, so what I did was I said, here's the pattern that I'm matching against, and I carefully constructed it so it was usable as a map key in Go, and then that made it really easy to check the patterns against the pattern of pots. So that's what I did, and yeah, the thing that was difficult here was when you have a repeat, you have to be careful to set the size of the repeat correctly and to be careful with your math. One way of doing it is just repeatedly incrementing by that number of generations or a multiple thereof, and then manually iterating. And that probably would have been easier for me rather than doing what I did, but so it goes. So I struggled a little bit. I had off by 1 error. It happens. Day number 13. Oh my god, this one was so fun. This one probably is very high on my list of favorite puzzles. And the reason was that it involved, who doesn't like having simulating a bunch of go-karts smashing into each other and so forth, so on and so forth. So this one was relatively straightforward as far as it gave you a set of instructions, and it was a test of can you actually translate the written instructions of, okay, these are the things that the carts do, these are so on and so forth. But the trick was actually implementing it concretely. So, yeah, I actually think it was moderately difficult in that you had to keep a lot of different stuff in your head. Like, you had to parse the board into a set of rails, you had to keep track of the carts, and which direction they most recently turned, / which direction they were about to turn. And so on and so forth. And then it makes you also potentially have to remove pairs of carts and make them inoperative so they don't continue moving and crashing into things as you go. So I thought this was super, super fun. It was definitely one of my favorite puzzles, and I felt kind of was in the right vein of difficulty for someone who isn't necessarily super computer sciencey but wants to figure out how to make something go. No pun intended. Day number 14. This one was the digit summing. Oh, this one. So I was asked to sum up, I think, a ridiculous number of recipes. This required detecting the pattern and then iterating it out. So this required a bunch of effort, in particular to go past the number of recipes in order to get the total set of recipes afterwards. And it also was something weird where there is a reliable repeating pattern, but you had to look out for it in order to figure out what was going on with the puzzle. So I think that this one was pretty difficult, and I had an okay amount of fun. Like, this one was definitely not one of my favorite puzzles. You oomed on part B of this puzzle, A9? Right, day 15. So, day 15 is the very, very, very infamous day 15. This, I think, was the single puzzle that gave almost everyone the most difficulty. That gave the most difficulty to everyone. I also had fun doing this, but it was kind of type 2 fun, in that it was really frustrating and aggravating to try to figure out what was broken in my puzzle, because there were so many things that you could potentially get wrong. Because this one had a bunch of stuff that was hella complicated because of the fact that you very well might have the wrong tiebreaker, and you generate the correct result on every single sample. Your movement would be subtly different, so if you stepped it forward, you would get exactly what you expected. But if you didn't and you just looked at the answer, you would think that you had it correct. The other thing that was really subtle and really made this type 2 fun for me was the fact that the ending condition was not what you think. The ending condition was not, there's only one side alive. No. The ending condition was, it's the first round in which someone attempts to attack and cannot find someone to attack. So it might be the turn after everyone dies. Or, if you killed someone, if you killed all the units of a type, and then you still have one more unit of the opposing side that can go, then it might end on that turn. So that really, really threw me, and that, I think, was the frustrating part about this puzzle. It was that there was so many nitty-gritty details. Blargle, I've been at my desk for 5 days. I've been home for 5 days since the 19th, so... Yeah, so this was kind of Dungeons & Dragons Simulator. It was fun, and it was super rewarding. I just know that a lot of people found it frustrating. Okay, day number 16. So, in day number 16, this is where we get introduced to the assembly machine. Trying to remember what was tricky about this one. Oh, this one had a really funny gotcha.
That's bullshit.
The really funny gotcha was that you were asked to determine how many opcodes could possibly resolve to the same opcode, which was easy enough for the case of just, okay, how many resolve to 3 or more opcodes? But then it got more difficult. The thing that got more difficult was if you just tried to solve it by saying, okay, I'm going to use process of elimination, what things only have one opcode they resolve to, you wouldn't actually find a definitive answer. Because it turns out that there was this really funny kind of almost triangle where you had to, once you'd resolved and said, okay, opcode number 2 is this operand, and you had to remove that operand as a possible result for all the other opcodes, and then you would actually get the correct result. Because eliminating one down to one possibility would cause another one to be eliminated down to one possibility, and so on and so on. So, I thought this was definitely quite fun. It was certainly modestly difficult, because of the fact that you had to write every single operation, and you also had to write the virtual machine. So, that's what I thought about this one. Let's see, this was day... Oops, I clicked on day 17 by accident. So in day 16, I ultimately wound up refactoring this, and I wound up creating a assembly library that basically listed out, okay, here's add, here's multiply, here's Boolean OR, and so on and so forth. Okay, so that was day number 17. What happened in day 18 was definitely a extremely fun puzzle. This was definitely, I think, one of my favorite puzzles. This one was a... Depending on what happened in your neighboring tiles, you would flip the kind of tile that you were, so it was almost a game of life type puzzle. And again, the tricky thing that was involved was it asked you to evaluate it for the long term, which required you to detect the loop rather than having to repeat it over and over again. So I thought it was not that difficult. I thought it was super, super fun. Wait, did I skip 17? Crap. Thank you. Okay, so let's do 18 really fast and we'll go back to 17. So yeah. 18 had the fun thing of, you had to make sure that you would detect duplicate board states, which again requires encoding in a way that Go can detect repeats, and you can use it as the key of a map, which requires that it be equals comparable. But fortunately, Go takes care of that for us, so we have this lovely state machine, which I think works quite well. Okay, back to day 17. Oh, day number 17. Day number 17 was the water filling puzzle. Oh, what can I say about this puzzle? The thing that really, really infuriated me about this puzzle was the fact that the example here shows the first bit of clay being present on the very first row. However, in my input, the clay was present like 4 rows down, which meant that I was mistakenly adding a few extra tiles of water that were present in the initial water spout to my count of tiles with water. And that was not so great, because that caused my answer to be wrong, which caused me to struggle and struggle and struggle. The other interesting thing here was that it required a fair bit of backtracking. It specifically required having the ability to record and check, hey, if I'm about to add a tile of water, where do I put it? Do I put it to the side? Do I put it up? Do I let it trickle down? You know, so there are a whole bunch of really intricate things that need to happen here in order to make sure that you could actually you could actually properly resolve where each piece of water was supposed to land, as well as remembering which things were just transient water flows and which things were actually places where water was collecting. I'm going to rank this as a 6, but I'm going to notice that this was really frustrating due to a lack of one of the examples. Not having that test condition of having the water or the clay start below the surface. Okay. Day number 19. Day number 19, I am very much going to spoiler you. So day number 19 finally introduces the idea of the program counter and actually having a proper instruction pointer and a proper CPU. And this one required you to disassemble it. If you did not disassemble it, you're going to have a really bad time. So I wound up taking each piece of code, and I wound up converting it to assembly, or converting it to Go code. I know some people wrote some decompilers here. And what turns out to be the case... Hi, can you please not? Good night. So it turns out that it's trying to do a really, really slow operation of multiplying x times y and checking to see whether it equals the number we're trying to factor, and incrementing x and y one at a time, because there's no division in this language. However, we have division in Go, so it turns out that we can compute the factors and we can add the sums and get the sum of factors relatively easily, just emulating that particular function within the disassembly. So I thought that was pretty fun. I really enjoyed getting a chance to do a little bit of disassembly. It felt like good detective work. It felt pretty fun. But it was modestly difficult, I'd say. Day number 20. So in day number 20, we wound up having to do our first kind of real set of map exploration, and map exploration in a way that I have never seen before. Specifically, it gave you a regex. And at first I thought, okay, well, I can just test each potential subpath and see whether it matches the regex, but then I realized that's a really, really bad idea. That's not actually going to cause me to get what I need. And not only is it going to cause me to not get what I need, it's going to be really, really slow. So I decided not to do that. And then I decided instead to write a parser. Writing a parser was definitely the correct move here. So I actually wound up writing something that tries to parse the regex from scratch, right? So it keeps track of what's in my current sequence of letters that I'm matching, what are the potential alternatives that could come after me, and then who do I run after myself, my alternatives, which payload do I run next? So that's what I used. And at first, I was trying to generate every single possible string of solutions. And that actually out of memory to my computer. And I think I had to reboot it or restart my stream or something really, really bad. It kind of really sucked. But then I realized I don't have to keep every string in memory. All I have to do is keep track of, if I'm told to go north and there's not a door there, I just smash through the wall and make a door. So that was a key realization, and that caused me to be able to solve the puzzle. So I think that it definitely was fairly high up there in difficulty. Not quite as high in difficulty as Beverage Bandits, but definitely pretty high in difficulty. And it was definitely one of my candidates for for very favorite. Okay. 4 more puzzles to review in 15 minutes. I think I can do this. Okay. Day number 21. For day number 21, we had to figure out what are the values that cause this mystery program to halt. And not only the first value that could potentially cause it to halt, but all values that could cause it to halt. So I initially started off disassembling the whole thing to try to figure out, okay, what is this doing? And not only that, I messed it up. And I'm really mad about it. This I had written down initially incorrectly as greater than 256, not greater than or equal to. And it caused the output of my disassembly to diverge from the actual output of the program. And that cost me a bunch of time. And not only that, it wasn't even necessary to do that. It turns out that the best thing to do would have been find the expensive operation, which turns out to be trying to divide the current number by 256. And what I could have done was just use a simple bit shift or divide in Go and substitute it into the loop of the processor when I encountered the mystery function, and then exit from the mystery function as if nothing had happened. So I ultimately wound up figuring out that approach, and it did work. The other thing that I needed to do here was, you don't actually need to disassemble the whole thing. You just need to look for, okay, where is this going to terminate, and what will cause it to terminate? And it turns out that the thing that causes it to terminate is here. Yes. The thing that causes it to terminate is right in here. We're told to jump off the end of the program, which causes it to terminate. However, if you know that if you get to line 28, then you need to record the value in register number 3. If I'd known that, I could have solved it a lot faster. So it turns out that the simple thing to do is just check if we're at assembly instruction number 28, record the value in register 3. That's all you need to do. Not a big deal. Not too difficult. So it wound up being pretty rewarding, but also wound up being a little bit challenging because of the fact that you had to figure out both what was the slow code doing, as well as figure out that you didn't need to actually mathematically compute the answer, just simulate it and record what value causes this value to causes the equality to match. So I thought that one was pretty fun, right? I think it was a good balance of challenge and fun. I don't feel it was unnecessarily punitive. I just happened to take the wrong approach with it. Day number 22. What did we do in day 22? Day number 22 was calculating, first of all, making sure that you have the correct procedurally generated terrain. And then secondly, doing a breadth-first search to find out what's the best possible path. Well, I guess technically an A-star search is the correct search technique. This one was the cave splunking. And the trick here, which I got pretty quickly, I know that other people struggled with, was the idea to, because of the fact that you have to have specific equipment on at specific types of terrain, and because of the fact that you have to take time to switch between equipment, I modeled each of the different states as a separate node and constructed the graph that way. Other people who didn't do that really struggled a lot more with it. The other interesting thing that I did was I wound up using a little bit of a heuristic to figure out, okay, if I figure out a faster path to get to a given location, then I have to go through and update all the other paths that are nearby to make sure that anything that depended upon that path now has the distance to get there shortened, so that I'm always using the shortest possible path. And it also potentially involves going beyond and overshooting the reindeer that we're trying to rescue and coming back. So I thought this was pretty rewarding, but at the same time, I do think that it was fairly difficult. It's definitely one of my favorites. Day number 23. So for day 23, oh my god, this one. This one was using Manhattan distances. You had to intersect various octahedra with each other to find out which point in a very, very, very large integral coordinate space has the highest number of octahedra that it's inside. And my approach here was basically to start from each of the center of the octahedra and then take steps until you barely touch each neighboring octahedra, and then order by the closest that you have to move. And then to iterate that process over and over, always increasing the number of octahedra that you're touching. And it generated a result that was correct. However, the result that you're asked for here is you're asked to generate the number of the sum of the x, y, and z coordinates. And it turns out that a weird property of octahedron edges means that if you're anywhere on an edge of an octahedron, if you get lucky, that's not the global maximum, you still might get the correct answer because the edge of the octahedron can be encoded as essentially, say the x coordinate is held fixed at a given value, then the y and z coordinates might be step up 1 and step up 1 at the same time, or step up 1 and step down 1 on each of the axes. And if so, the sum remains invariant even as you move along the line. So I wound up having to revise this code a bunch of time afterwards. I talked to Topaz about the origin of the puzzle. So it winds up being the case that you can get a suboptimal answer that passes all of the tests. But if you just walk along that line, you can actually find the global maximum point just by walking along each of the 12 possible lines and then seeing which one leads you in the direction uphill of having more octahedra intersect with yours. This one was definitely, I think, one of the most difficult puzzles of the entire batch. I think that all in all, it was moderately fun, but I think that, I don't know. I think the fact that some people got lucky and could answer correct with the wrong answer is not good. And I also think that the fact that a lot of people instantly got it with a R3 solver rather than using their usual programming toolkit makes this one a little bit cheesy. So I don't think it's one of my faves as constructed. But I do think I learned the most from this one.
My 3 trees are legit. I work in geospatial. I don't know what you want.
All right. And then finally, day number 24. So for day number 24, it was a pretty elaborate kind of net hack, or not net hack. It was almost like simulating magic in that each thing picks one thing to target and then targets it and then deals damage to it and then repeat and so on and so forth. So this one was difficult primarily because of the parsing. The actual code was not that difficult. It was okay. It was just very parsing heavy. So, that's my assessment of all of the 24 puzzles that we've seen so far. And if I were to rank them by which ones were my favorite, I would definitely put day number 20 pretty high up there. I would put day number 15 probably very high up there. And then I would also put day number 20 pretty high up there. Actually, wait a second. I can just sort these by fun. Why don't I sort these by fun?
Write a sorting function, coward.
I'm using a spreadsheet. I'm entitled to use a spreadsheet.
Sorry.
Sort by fun, inverse, go. Okay. Yeah. I definitely think I'm going to demote day 15 because it was type 2 fun. Sorry. Yeah. Go with the flow. I feel that was day 19. Oh yeah, no, day 19 was not bad. Yeah. So I think this is kind of my assessment of which ones were my favorite. So if you're picking a puzzle to work on and you want to skip ahead, I'd strongly suggest skipping ahead to day number 18 or day number 20 or day number 13. Or maybe day number 22. I think those are kind of the most fun of all of them that I saw. The rest were pretty good. And I think that kind of frankly, I think day 24 was a little bit of a letdown in that it was pretty parsing heavy and not actually a head scratcher as far as algorithms. Cool. I'm probably going to go cut the stream for a couple of minutes and say goodnight to people before day number 25. So I'll see you in all about 5 minutes.